Hello, welcome. In this video you will learn how you can make Atyrau Bridge in Rhino and GRasshopper. Location Kazakhstan. Drag and drop reference picture into Rhino canvas. You can download the reference picture from the description. Draw a rectangle and trim unnecessary part of the reference picture with it. Create new layer and change the reference picture layer to it. Lock the layer. Change the transparency of the reference picture. Draw a polyline. Offset. Set the offset distance manually. Do the same process to another side. Blend curve. Control the blending by sliding. Select all curve and join. Select all curve and type subdiloft. In subdiloft option, check corner option. If you get weird result, check adjust curve segment and increase or decrease segments. Change the curves to another layer and hide it. Now the topology is 9 uniform, some edges are crossing. We use quad remesher to fix it. Change target count to 50. Check convert to sub-D and sub-D corners option. Change the original sub-D layer and hide it. Hide reference picture layer. Offset sub-D. Make sure you set solid to yes. Insert edge. Set both side to yes and offset mode to proportional. Select edge loop by hold down Ctrl, Shift and double click on it. Crease. Select the face and extrude downward. Select these edge loop and duplicate them. Now open Grasshopper and reference those curves. Hide all geometry. Create perpendicular frames on the middle curve and find the intersection between the plane and the remaining two curves. We can control the number of places by n values. Next, find the intersection point between the places and those two curves. Use curve plane intersection component. Craft the curves. This make the data structure of two branches. This helps to calculate the intersection of each plane to these two curves. If the endpoint of the curve is not aligned, the intersection on the first and last plane will fail. So remove the first and last planes. Now let's restore our data structure to the previous one. The previous one has two branches, so offset with the value of -1 gives us back to it. By using the explode tree component, we can separate each branches. Next, create arc in the direction start for branch 1 and end into branch 2. We can control the height of the arc by using scale 9 uniform component. Next goal is to split the arcs into this kind of shapes. To visualize the splitting point, I use evaluate curve component. Reparameterize the curve, so the curve domain will be 0 to 1. By generating a range of numbers between 0 and 1, we can control the position where the split point will be. At expiration x minus 1 to match the numbers of ranges to the list length of the arcs. Next, use Graph Mapper. Graph Mapper allows us to change these value according to the y position of the curve inside it. For better control these values, use remap number. It remaps values from one numeric domain to another. Add expression 1 minus x. This makes the evaluation position start from the endpoint of the curve, and merge these two values. Graph them so we get two branches. Also graph the curve input to match the data structure. Now we can split the curve into 3 segments using shatter component. The separation point is the same place as these point location. In each branch we have 3 segments of arc. Remove the middle segment by using call index component with index of 1. Now we have 58 branches. In each branch, we have 2 items. By using flip matrix you can flip the data structure into 2 branches and 58 items in each. Now we can make loft in each branch separately. Next, separate the lofted surface into 5 different subsurfaces. Use isotrim to separate surfaces. Make separation domain. First make consecutive domain between 0 to 1. From that, we can create U and V division using the construct domain square component. Create 6 sequence number between 0 to 1 and connect to consecutive domain. By default additive is true. That means the domain values are added to sum total, so invert the boolean. Next, by using construct domain square create U and V domains. By using this we can separate surfaces. By using list item we can select each surface separately. Next we are going to make each panels. Triangle panel B from lunchbox. We can control how many panel in U and V direction by connecting number sliders. Extract each panel boundaries. Scale each boundaries from their center. Next, we can use basic curve attractors to influence the scale of each panel. We measure distance from each point of this curve using pull point component. After that, we can remap the distance values to what we specified. Move each cells to their normal direction. To get the normal direction, we can bias planar component. From the plane output, we can extract the z direction by deconstruct plane component. We can scale the vectors by multiplying. Explode the cells into 3 segments and scale at the midpoint. Do the same process for the originals too. Merge these 2 set of curves. Craft both of them so we can create loft between each 2 pair of segments. Join and wield from Weaverbird plugin. Shift path with negative value until you get 2 branches. Give thickness to the mesh. Change the offset direction by set expression to -x. We have shading problem here. By unwelding the mesh we can fix it. Now we can apply the same proximity techniques to the remaining surfaces. It is the same process as the previous one, just copy and paste. Most of the time I use the mesh process because it's a bit faster process and easy for UV unwrapping. Here is the final. Thanks for watching. See you in the next video.